All right, hey guys, this is Mr. Cunningham. I'm back. This will be for Wednesday. Talking about triangles here and solving the interior angles for a triangle algebraically. We're gonna be looking at those now. Some places in the real world where this is definitely kind of used. Maybe not so algebraically on some parts of it. Is if you ever heard of a speed square before? If you're a carpenter, speed squares are pretty important. I've used speed squares before, helping building barns and stuff like that as a teenager and stuff like that with my dad's farm, building a barn and a garage and stuff like that. I've used speed squares on doing a basement, but they have degrees on them, and they help you make your angles. For example, like on a rafter, I believe it's 27 degrees is the normal cut on a speed square. And the speed square, it's not a square at all. It's actually a triangle. You can look it up if you'd like. But it helps the carpenter make precise lines on the piece of wood that they're cutting so that they know exactly what degree they're doing. And so they make something that is square. In other words, when they say square, that means level, even. And so 27 degrees is usually on I think, believe it would be a slope of 6 to 12. So um, next year, eighth grade, you'll talk about slope and stuff like that. But 6 to 12 would be the rise and run of the rafter. How steep is that? Is that now? If you look at houses and stuff as you drive in a car or something, like you look at houses, you'll notice that there are roofs that are different slopes. Some are very steep, and those shingles actually last longer if there's a steeper slope. However, it can be very dangerous to be working on those without being tied in. But obviously, the slope and the cut on that would have to be more dramatic on a roof like that. So, triangle angles there can have an impact how you're cutting them. So, but right now we're just in math. We're going to be doing finding the interior angles of them. So, for example, let's say we have um, an obtuse, and let's say scalene triangle. So we have 120 degrees, right? And then let's say we have 40 degrees. And so we want to find this one. Now, remember, we know that triangles from our last session, triangles have to equal 180 degrees inside of them. All triangles have to be that way no matter what we do. All triangles have to be 180 degrees total. So when we look at this, all these angles here, if they're added up, have to equal 180 degrees. So we have x for one angle plus 120 plus 40 have to equal 180. And so what this basically turns into is just a um, problem that we have to solve, an equation. All right. So we can combine like terms. We're supposed to combine like terms. So we can combine like terms. We have 160. So x plus, combine these two constants. 160 was 180. Now, some of you may know the answer right off bat, but we can do our inverse operation. Subtract our 160 from both sides, and x equals 20 degrees. Now, I want you to know something about this also, is that notice that the angle measures and the side that they're with, okay? Whichever angle has the biggest angle, whichever angle is the biggest, has the biggest side opposite of that. That's kind of important when we get into our later in this chapter with making triangles by hand. Now, unfortunately, you won't be able to make those. You'll have to see me making them and talking about that, and answer questions based off that, whether they are it's a side, and stuff that can work. Um, that's kind of the bad part about not being in school because we need to use some instruments. We actually need to hands on with this standard. It's kind of hard to do, but one thing to understand is that the bigger the angle, the bigger the opposite side is going to be. So 120 degrees is the biggest angle. That means the side opposite is the biggest side. And this one, in this case, is a hypotenuse. 40 degrees is the second biggest and has the second biggest side. 20 degrees has the smallest side opposite. This is the smallest side, and 20 degrees opens up to that. Think of, like, for example, a projector. If you've ever seen a projector at any point in time, maybe not anymore, um, mostly because I'm old and that was 20 years ago. But we used to use projectors to put TV screens on, movie screens on at like parties and stuff like that, or even play video games on. And so you'd have to make a bigger angle to make your picture bigger. But the problem was with the projector, it'd make a rougher picture. So, but this is what we're doing, and we're going to apply that algebraically. So, um, now if I did an equilateral triangle, that's pretty easy. Equilateral triangle is 60 degrees all the way across. Doesn't matter what we do. Um, so let's look at another one. Um, so we're going to say this is 27 degrees right there. And we're going to say this is 48 degrees. And this is X degrees. Now, we already know which side is the biggest side. So we want to take that into effect. That this side's huge. Okay. So we know that that angle has to be the biggest angle because it's opposite that angle. It is the biggest side. We know that angle has to be the biggest one. 27 has the smallest. 48 has the second largest. Okay. So we're going to add those together. We know that has to equal 180 again. 180 degrees again. So 48 plus 27 plus X. We can add those together. And so that's going to give us 75 equals 180. And we know how to do a one-step equation. Subtract 75 from both sides, 75 plus X. Well, we can find that out by subtracting 75, inverse operations from that. And that gives us X equals 105 degrees. So that one is 105 degrees. May not look like it, but in geometry, you will learn that not to trust what your eye see. And especially since I'm drawing it, it's not going to be exact. Okay. But that's how we do that. So let's look at one more. Well, we're doing a little bit more than just one more, but 4 different ones. Once again, I hope everyone's doing well. Get some fresh air when the sun is out and nice. Let's see here. So we have a 90-degree one. Remember that little box tells us it is a 90 degree, right? So red box tells us it is a 90 degree. So we have that. We have 63 degrees. So this one will be 63 degrees. This one will be X. So sometimes they might not give you exactly everything. So this is 63 and 90 degrees X. They give you this, they are giving you an angle measure. And you should know that that's 90 degrees. So we add that together, we get 90 plus 63 plus X equals 180 degrees. So we're going to go ahead and add these combined like terms, 100 and we got 153 plus X equals 180. So we subtract our 153 from 180. X equals 27 degrees. So there's what we have there. Now let's try that a little bit more algebraically. I'll try that a little bit more algebraically. So, and once again, you're probably not going to run in this kind of a part into probably real world situations. But they can ask this on a test. They can ask this algebraically when solving these types of questions. So we have one that is 45 degrees. So this one is 45 degrees. This one's 33 degrees. I'm trying to make this a little bit bigger. Hopefully you can see it. And this one is going to be 2x plus 10. Now, remember, we just added another expression here. We're going to add these together. And so we have 45 degrees here, 33, 2x plus 10. Remember, we can combine like terms. We know all these should equal 180 degrees no matter what. They should equal to be 180 degrees no matter what. So we have 180 degrees. We have 45. Add those together. 2x plus 10 plus 33. Now we can go ahead and combine like terms. Remember, the variable has to go with the same variable. There's no other variable here that's x. Therefore, 2x is going to stay the same no matter what. So, but 45, 10, and 33 are all constants. And remember, they're constants because we're not changing them. We're just going to put them together. And since they're all constants, we can put those together. So 45 plus 10 is 55. 55 plus 33 is going to be 88. So we have 88 plus 2x, 180. So now we can do our two-step equation. Now remember, you can order this any way you want to. If you want to order it 2x plus 88 equals 180, you can do it that way also. And that's probably what you're more familiar with. You're like, oh yeah, I can do that. Subtract my 88 from 180, 92 equals 2x. And so 2x, divide that by 2, x equals 46. Now, the thing is, they may ask, what's the value of x? And x equals 46 is the answer. However, they may also ask, what is the angle measure of that 2x plus 10? Well, we can figure that out. Okay, we found x is 46 if they ask for the value, and it may be a two-part question. They may say, hey, what's the value of the variable? And then what is the value or the degree angle of that measurement? So we can put that in there. 46 times 2 is 92. 92 plus 10 is going to be 92. Right? So 102. So 92 102 degrees is that angle measure. Okay, so we have 102 degrees for the angle measure, and this is obviously an obtuse scaling triangle. They got one obtuse angle. Okay, so let's do a couple more, two more. This one's going to have nothing but algebra in it. Like they all have algebra in it. Just solving for it. So let's go here. We have x degrees. We have 3x. And we have 5x. So we don't really have a constant here at all, but we have 3x, we have 1x, and we have 5x. Now, once again, we know that a triangle adds up to be 180 degrees. So we know it equals 180 degrees. We can combine like terms. Well, hey, 3x, 5x, and 1x are all like terms, so I can add those together. 5 plus 3 plus 1 x's. Okay, remember, it's just an x. So I can say 5 apples plus 3 apples plus 1 apples. We know how many apples there are. There are 9 apples, or 9 x's in this case. So 9x. And then we can solve for our value of x. And we can also then, therefore, solve for the value of the degree angles for each angle. So divide by 9, x equals 20. So I can plug those in. So I know this one is 20 degrees because it's just 1x. I know 5 times 20 is 100 degrees. So this angle over here is 100 degrees, whether that be A, B, or C, angle, whatever. And then this one, 3 times 20 is 60x. Oh, 60 degrees, sorry. So 60 degrees. And so therefore, we have it solved, and we know everything has to be 100 degrees. So we have the interior angle solved and the measurements of those solved. All right. Let's do one more of those. All right, so we have an obtuse, not too obtuse. We have 2x plus 5, 2x plus 15, sorry. That's 2x plus 15. This one is 7x, and this one is 2x. So once again, we know the interior angles of a triangle have to equal 180 degrees. So it has to equal 180 degrees, make it equal 180 degrees. We combine like terms. We have 2x, 7x, and 2 more x's. Well, those x's can combine. So 2x plus 7x plus 2x, 11x. There's only one constant here. There's no other constants here at all. So plus 15. Now we're back to our good old two-step equation. And remember, you may have to just solve for the variable and then also find angle measures. And trust me, you're going to do a lot of this next year in 8th grade. A lot of this stuff you'll do a lot next year with the angles. So subtract 15. So 11x 11 minus 15 is going to be 165. Okay. So 11 goes into that 15 times. We divide by 11. Okay. So x equals 15. So now we can plug those in. So 15 times 2x is 30 degrees. 15 times 2 is 30 degrees also, but plus 15. So this is 45 degrees. And 7 times 15 is 105 degrees. And so we have all three of those angle measures that we need to know. And so that is finding the interior angles of a triangle, what we need to be able to do. I'll add some questions here on this as well. All right. I hope once again everyone's doing a good job keeping up on your. Well, first of all, everyone's doing a great job on trying to keep up with your learning and so forth. Today I saw Mike DeWine, our governor, talk about how we may not go back till May 1st would be the deadline till we go maybe possibly go back to school. We'll see. And once again, you're going to learn the things you need to know to move on for seventh grade. And like I said, the good thing is that we've covered mostly everything. But next year, I'm trying to also prepare you for next year also, and that way you don't skip a beat. And it's definitely different than what we normally do. Just like when we start doing the making triangles, it's pretty important to what we do in seventh grade. Um, Unfortunately, you're not going to be able to make them with me, and that is important for hands-on for that. So that is an issue, but you know, it's you're going to learn what you want to learn out of this. You put your effort into it, and most of you have been doing it, and I really appreciate that. You guys are giving a good job to your education, and that's important. That says a lot about your character and who you are as a person, and that's important. So good job, and being successful is not easy. I say that throughout the year. Success waits for no one, and it's not easy. If it was easy, then everybody would be successful. But unfortunately, that isn't the case. It's hard work, and you guys are doing a great job, and I appreciate that. And don't ever be afraid to ask me questions if you're stuck on something. I know some of you reached out to me already and talked about certain things and questions you have, and that's quite all right. Also, if you're missing something, I'm not going to count it late. So you need to try to get into me as soon as possible and get that done before the end of the school year. So I'll talk to you guys later, and I will be posting this up on Edpuzzle once. No, you'll ever see on Edpuzzle, but put some questions on here. All right, thanks. Bye.